Okay. Thank you, Shrikant. And thank you, everybody, for being here. And thanks to Steve, Sunil, and others for giving this opportunity. I really enjoyed to be here. And we'll talk about cloud native. What prompted me to present this here was last time when I came, I was asking a lot of questions on cloud native. And Steve said, oh, you seem to know more about this. Can you give a presentation? And so that prompted me to prepare this. What we are doing in Cisco, our group is actually building a SaaS application in analytics portfolio, which is more foundational, very strategic, and we are using many of these principles. And so I just wanted to bring it out to you guys to see what is required to build a cloud-native application. As Shrikant was talking about, if you just port an existing application which is in a traditional data center to the cloud, it doesn't benefit from all the characteristics that are there, and we'll talk about what it is. So, what a cloud-native application is, we'll look at some of the definitions, and then we'll go from there. So, what's a cloud-native application? It's an application that's specifically developed for cloud platform. How many of you have previously heard about cloud native, other than Shrikant's presentation? Okay, great. So, I'm not talking about cloud native networking, but I'm talking about an application that's developed there and what principles it should use in this presentation. So, if it's specifically developed on a cloud platform, what's a cloud platform is the next question that comes up. And there are a host of definitions that are there on what cloud hosted, cloud-based, cloud-washed, cloud-optimized are all about. So let's just walk through some of them, right? A cloud is a computing environment where compute, network, and storage resources can be provisioned and released elastically. That's the fundamental definition. Now, if you put an application on cloud that doesn't leverage these kind of capabilities, then it's not native to cloud. So those could be something called cloud hosted, cloud based, or cloud washed is a funny word that I got from the net, where people just want to portray their application as cloud native, but it's not. So these are kind of the definitions that are there, and what we are really interested here is cloud optimized and cloud native. Well, cloud optimized is probably a traditional application that's developed to leverage the capabilities of the cloud, and a cloud native application is built in the cloud so that you will benefit from all the benefits, all the advantages, right? From the box, right? So we'll talk about more on cloud native because these ones should be built as a SaaS, software as a service. It should promote development agility. We'll talk about some of that aspect, whether it's acceptable to take 2 years to develop an application or whether we want to make it, whether we want to be agile in developing, enabling multi-tenancy, fast upgrades, scalable, all of those things. So that's cloud native. We'll look into more about that today. So what's the difference between a traditional application and a cloud native? A traditional application is a stateful application. You know where it's running. The application has a server stickiness. Whereas in a cloud native environment, it runs stateless. This is, for example, your Amazon shopping cart. You're doing something and something happens to your server, that server where the application is running, and if it is lost, then if you lose the context, then that's not a good thing for the user. Now, when an application is a cloud native app, when it runs in such environment, even if the app is lost, the context is shared across multiple apps. The application itself is running stateless, so you will not lose any context. So there is no server stickiness. We saw about how the server and the apps being tightly intertwined in the case of a traditional app, whereas if they're loosely coupled. Scaling in terms of in traditional apps, if you want to scale your application, you just need buy a big server and deploy it there. In case of cloud native, you just scale your app across multiple servers, commodity servers with elastic way of provisioning. So you don't need to be manually involved with the scaling at all. Now, we talked about the apps being lost when the server dies. And one major difference is, in traditional case, the servers are treated as pets. You have names for your servers. You have host name, IP address kind of thing. In case of cloud native, the servers are treated like cattle or herds. So if you have names, then it's a pet. Then it's not a traditional, it's not a cloud native environment. So why do we need cloud native? We looked at the example where Srikanth was talking about how the applications can have all these latency problems and all. When you migrate your traditional apps to cloud, all these problems can show up. Now, if you build an app on the cloud itself, which is meant for cloud, then all these problems will not be there. But the bigger advantages are, with cloud native, you want to be able to deploy it very quickly. You want to be able to develop things, develop applications very fast. These days, when you cannot afford to take months and months to develop software or provide increments into the user environment, you want to be able to deploy very quickly, and cloud native allows you to do that. Supposing there is an error in your deployment. If you want to fix that error, you do another deployment to fix that. Now, if the deployment is a massive deployment that impacts everything that you have deployed, then that's not a cloud native type, and we are going to look at how you are able to partition your application and how you are able to incrementally update your environment. Those are all key for being able to innovate fast. Now, being fast is just not enough. You want to be able to do it with safety, availability, and stability. And it's not, you don't want to have to plan for months and months together to be able to do a deployment. What you want to be able to do is, even without having to plan, you can quickly and incrementally deploy your application or set of applications and provide capabilities to your consumers, to your users. And that's only possible by having the environment that supports that, which includes the monitoring, metrics, alerting capabilities, and then how you want to isolate your services that you deploy. We'll talk a little bit more about the microservices and containers and all of those things that make it cloud native. And again, independently deployable components so that there is no cascading failure, and being able to recover without human intervention. How you have your self-service agile infrastructure that looks at what's happening on the network, on your platform, and brings up alternate services when something goes down. So these are all very important for deploying a cloud native application in an environment. We talked about scale, being able to scale on commodity hardware horizontally rather than vertically. Vertically means bigger servers, horizontally means having more number of servers and distributing your application on all those servers, and being able to provide isolated workloads. That's very important for scaling cloud native. And then of course ubiquity, which is another one that Shrikant talked about, where you don't want to have latency in your applications that are being accessed from elsewhere. Some of these need to be provided by the platform, and we'll talk about how cloud platforms do provide these kind of things, and the applications need to leverage them. So, okay, let's come back. Okay, so let's look at some examples of how the traditional applications leverage the infrastructure and how cloud applications, cloud native applications leverage the infrastructure. In the first column, you see a traditional application which is deployed on on traditional hardware. The application probably needs to be aware of all these different layers. You know where the networking construct is, you know where storage is, servers are, all of those things. If you go to another environment where you have infrastructure as a service, where all these servers, storage and networking are virtualized, but you still need to be aware of the middleware, operating system, runtime environment, those kind of things, then your application has to understand all those things and work with that. In the cloud native case, what you find is that everything else is abstracted. Your applications do not worry about where your infrastructure is, where your resources are. You need to build your application such that there is a loose coupling between the application itself and the underlying infrastructure. We'll talk a little bit more about that, how to make that happen, but essentially, you can provide a platform as a service in between to make that happen. And they can come in multiple flavors. I'll show you a couple of examples, prescriptive or assembled platforms. And then we can discuss a little bit more. Any questions at this time? No? Yes?
Customer example we got, agility was not, development agility was not important for them, right? Their problem was different.
In this customer example, development agility was not the problem because the applications were already there. They had the traditional applications that had to be migrated to cloud, right, in a cloud environment. But going forward, the development agility is one of the most key factors when there is so much competition. You need to be able to provide capabilities to your customers very quickly. For example, Facebook has tens of deployments per day. Netflix has tens of deployments per day. How is it possible? It's because their applications are built in a cloud native fashion. Whereas you take any other traditional application, you need to plan for a month or two to make sure that the deployment goes through well. You can never even dream of having multiple deployments per day. I was in a conference 2 years ago, and one of the Netflix guys was giving a presentation. Before he came to the presentation remotely, this was in Florida, he made a deployment from there remotely and came there. How could he do that? It's because of the capabilities that are there to develop agile and deploy agile in an agile fashion. So yes, it's coming there. Most of the SaaS providers now that develop applications on the cloud, they are very fast. They deploy multiple times a day. So yes. So here is another view of difference between a traditional application where there is a tight coupling between the app and the infrastructure, and in the cloud native case, when a platform abstracts that, there is no coupling at all. Applications are oblivious of where their resources are, and the platform provides that abstraction, right? Which means that the applications have to be built assuming agile infrastructure, fragile infrastructure. So what does that mean? We'll talk about all those requirements, because only then you will be able to benefit from all the advantages that such a cloud platform provides. And when you build it that way, then only you can do the deployment in that fashion, only then you can scale at that rate. So these are some of the other requirements. Designing for anti-fragility, being loosely coupled. This is making an assumption that some of these are microservices based and all, we'll come to that. But why we want it loosely coupled is we want to be able to update, for example, Facebook, their whole infrastructure is not just one infrastructure. They can update parts of functionality incrementally without impacting anything else at all. And that's where the cloud applications are going. You don't want to, there will be millions of users. I mean, for Facebook there are over 500 million users, right? We don't want to have massive deployments which will bring everybody down. It will only impact a fraction of customers that are using a particular feature. And how do we deploy that incrementally is by having that kind of loosely coupled implementation, API-based collaboration, being able to abstract all the services. Again, here we are talking about embracing microservices approach and architecture. We'll see what that means. We need to make sure that our apps are ephemeral, which means that any state information is never kept in the app. So if you have another client coming, customer coming, and they bring up something, if an app dies, another app starts up and uses that shared state. When we say stateless, we actually mean shared state, because all the state information is abstracted out, right? No assumption of locality of resources, and then the following 12-factor applications pattern, and we'll talk about that. Okay, so what makes a cloud-native platform? We saw the need for speed, safety, scale, and ubiquity, which leads to emphasizing that we need to be able to deliver continuously, because when there are millions of customers, you want somebody or the other is always on. There is nothing like you can shut down your application at any time at all, right? So you should be able to deploy without breaking. So there isn't going to be finite amount of time that you can plan before deployment, which means it requires an operational discipline. We also want to minimize operational costs so that cost is available for development. Platforms should be, their support is very crucial, and then the monitoring is very important, because without good monitoring system, you won't be able to scale with safety, right? So again, looking at the platforms, there are two types that we can talk about, prescriptive and assembly, and I'll give a couple of examples of those platforms right now. This is one of the examples of a assembly type of platform. What it means is that we have all these open source components that are put together to provide a capability of a platform that provides that kind of an abstraction of the entire infrastructure, right? So this is actually, Cisco is working on with the open source community. It's called Mantle. There are a few presentations on YouTube and all. If you want, you can look at it. There are a few companies that are also working with Cisco to make this happen. This is an example of a assembly type of a platform. The other one is other platform. It's a prescriptive type of platform. There are so many prescriptive type of platforms, and here I've taken an example from Pivotal Cloud Foundry. How many of you have heard of Cloud Foundry? Okay, so cloudfoundry.org, they started with an open source platform. Pivotal took that and they deployed it across so many customers, and it provides wonderful capabilities for providing that kind of abstraction for the applications to reside in a multi-cloud environment, right? So you can see it's not easily visible, but all the capabilities that I talked about providing in the application framework, the platform runtime, logging metrics, messaging, all of those things, and it can sit on any of the infrastructure that is there that's currently available. So this provides the link between the application on the top to the underlying IaaS. And it's a very important aspect that these kind of platforms be available. The third platform that I'm going to give an example of is in Amazon. This is also something that we are using right now to build our cloud native application. So you don't have to use all the services here, but I've just marked some of the services that we are using to build our own cloud native platform that's on Amazon, and our application is using that thing. Now, with such a setup, any of the disadvantages that are there with the traditional app is not going to be there. Like Srikanth was talking about building new cloud native apps. I'm sure Azure also provides similar capabilities. We are just using Amazon for our deployment for now. So you can see that it has the container service, the RDS service, Elasticache, the load balancing, Route 53 for networking, the CloudWatch tool for monitoring, all of those kind of things we are using to build our application.
Can I ask a question?
Yeah, sure.
What is your thoughts on companies who prefer to build on IaaS as opposed to PaaS in terms of abstraction? So like Netflix prefers to go and control their deployment by doing an IaaS deployment.
They built their own PaaS actually.
Are they doing PaaS?
They built their own PaaS.
Yes, that's what I meant. So
Yeah.
you just rent the machines. Oh, sorry, thank you. So companies like Netflix obviously has huge intellectual property.
They were one of the pioneers. They built their own PaaS.
Right.
And so
moving that to AWS IaaS, and one of the disadvantages about tying yourself to managed services in Amazon is that if your application is actually, you care a lot about the IP and you have a lot of business logic in there, you might want to build an abstraction layer that allows you to move it to Azure.
I was actually going to make that comment as well. You need to be very careful about what services you're going to use here, so that if you really want to move somewhere else, this gives a good head start. I don't know, there are so many blogs that talk about using public cloud infrastructure to build your service, and then you're stuck with it, and then your costs go way up, and how do you offload yourself from those dependencies? You need to be cautious about that. I'm just giving a view into what is available that you can build your cloud native application.
I was just, okay, so I'm from Cisco as well. So I think you're building Spectre. So this is going to be, that's something that runs on AWS, is that right?
It runs on CIS, it also runs on AWS.
Okay, that's great.
Yeah.
So that means you built abstraction layer.
Yeah.
Okay, thanks.
Well, we are using Mantle for CIS, and we are using these capabilities for AWS.
What is CIS?
It's Cloud Infrastructure Services, Cisco's cloud.
Oh,
That's their own internal cloud for serving.
Yeah, it's a
VMs.
Cisco,
serving,
it's not a public cloud, but it's
serving,
specific to,
BUs.
yeah.
several
internal.
Internal.
BUs. So what is it built on?
No, it's not just serving BUs. It has a public interface also. It can be a public cloud, but
It's OpenStack.
OpenStack,
OpenStack.
yes.
Hate
So-
OpenStack.
Huh? Okay. So you can go like AWS, you can subscribe, you can do your own thing, or?
I don't think we market it to compete with AWS
Yeah.
I see.
or Google Cloud Platform.
Actually, Telstra There are some other companies that are using CIS to build that kind of a
And one of the biggest
capability.
customers is Cisco IT.
Cisco
Got it.
IT builds cities, right?
Yeah.
That's same as CIS?
No, so
I don't know.
Okay, never mind.
CES. No.
okay. So let's come to the requirements in terms of what cloud native applications need to do, how they can leverage the platform capabilities that are there to build applications that are agile, that can scale easily, that are safe to scale, that are ubiquitous to access, those kind of things, right? So some of the main characteristics are, the first one that comes up is the 12-factor applications. How many of you have heard of 12-factor, 12factor.net? It's a platform, it's a set of requirements that developers from Heroku, which is another cloud native platform that they had built, Heroku, and they actually quantified what are the requirements for an application that need to be built so that it will leverage all the platform capabilities on a cloud, right? So we'll talk a little bit more about that. It's a set of patterns that optimize the application design for speed, safety, and scale. Microservices, I think there's a lot of buzz about microservices and containers and all. I think most of you would have heard about microservices, and we'll talk a little bit more about what's involved in that and how microservices help in building scaled applications on the cloud. Self-service agile infrastructure is very important because we want to be able to deploy on the cloud very quickly. API-based collaboration, we talked about the loose coupling and interacting with each other microservices. Anti-fragility, as we scale, we don't want systems to break, and monitoring. So, an overview for 12-factor using declarative formats. See, basically, all of these things are something that a good application must do anyways, regardless of whether it's on the cloud or not. But what happens is when you develop something for the cloud, it becomes very important so that you benefit from all the good design practices. So, declarative formats, having a clean contract with the underlying operating system or between various elements within their service, how you want to be able to deploy on all the modern cloud platforms, minimizing divergence between production and development, and how to scale up without making significant changes to the architecture. These are all some of the overview. In terms of details, these are the 12 factors. I'm not sure if I want to go through each one of them, but basically what we want to do is that we need to have one code base. We don't want any divergence from one environment to another, which is a common practice generally, but in some implementations we end up fixing things here and there and diverge between environments, which is not recommended at all yes.
I think that also applies in terms of where you develop the code. The development process, the testing process, and the operations process is essentially the same versus having separate.
That's correct. That's correct. We want to have the dependencies declared well. We want to have the configuration stored in the environment, not in the code, because the same code can get deployed to multiple environments. We want to make sure that the services that we attach to don't make an assumption of whether it's a local service or a remote service or what is latency, those kind of things. We want to make sure that we strictly separate the build and run stages. So we don't make changes in a runtime environment and think that that will get propagated into development time. Every change has to be made in the development time itself and has to be propagated through. Stateless processes, we talked about that. Exposing services through port binding, we don't want to have another container to host these services. We want it to be natively bound. Scaling out to the process model. Processes are the take a very important role. If you look at how basic Unix design was, essentially everything that was there is still valid here. So it's nothing really remarkably new, but what 12-factor has done is to reiterate that it's very important. Disposability, we talked about how services can go down and come up quickly because they are disposable and you can scale very quickly, so you can bring up new services as you need them to scale horizontally. Dev prod parity we talked about. Logs, treating logs as event streams. We don't want to have a lot of intelligence built into the code for treating your logs. In Unix, you know how to pipe it to standard out. Treating that way is a good practice, even here in 12-factor applications. And then admin processes, whatever we want to run as one-off processes should also be packaged as part of the product. They don't say that all these things are mandatory, but these are all the best practices and they're highly recommended. The next aspect is on microservices for a cloud native, very important part of microservices. There are a few definitions what a microservice is. How many of you are familiar with service-oriented architecture, SOA? Stephen knows all of the ones. So, this is a definition that Adrian Cockcraft, Netflix cloud architect, brought up. It's loosely coupled service-oriented architecture with bounded context. Sam Newman wrote a great book on microservices. He talks about how these are small focus components that can be built to do a single thing well. And then here is the Wikipedia definition. And then James Lewis and Martin Fowler are some of the outspoken architects on microservices. And they have a whole bunch of presentations and blogs that are there on microservices if you are interested, and very good material for reading. Here is an example of what a microservice architecture would be looking like. If there are multiple applications that can sit in a single process, a microservices architecture puts each element in its own service. Characteristics. So I'll not go through all of these in detail. I think it's getting late, but so componentization, we talked about it. One of the things that we talk about in microservices is to organize around business capabilities. This is the same kind of thing that we talk about even in agile development, where we want vertical slicing of functionality, and we organize microservices along the same architecture. We want to think long-term in terms of products, not just projects. Smart endpoints and dumb pipes, the logic is all inside a microservice, not across. Decentralized governance, decentralized data management. We want to orient all the governance and data management with the microservice itself. They can be done through they can be using multiple technologies, but we want to make sure what's best for that service we need to enable. Infrastructure automation, we talked about how automation is very important. When you have hundreds of microservices, you cannot afford to make anything manual there. Everything has to be automated. Designing for failure, that's how you scale and how you build fault-tolerant system. And then evolutionary design and architecture. Here is the other example, how you want to scale. If you have multiple services running on a server, this is the traditional way. But if you want to scale, you have all these individual services come up, scale in their own servers so that we don't have to package them in the other way. So that's an example of how microservices can scale. So these help in building the native, cloud-native apps. Then, how many of you have heard of containers and Docker? So you guys are using Docker here? No? Yes? Okay. So Docker has become very popular in terms of containers. We are using Docker as well for our development. And here is a view of what a container provides versus what a traditional system provides, where it's quite light in terms of infrastructure usage. So stateless and ephemeral, we talked about that, making it stateless. Docker again promotes the same thing, using Docker ignore file for file usage. We don't want unnecessary packages. These are all mostly common sense. We want to make it as lightweight as possible. One process per container. Sometimes it feels that you can package too many processes in one container, but the recommendation is to have one microservice, one process per container. Minimizing the number of layers, tagging the images so that it's readable, know what you're deploying, and then don't map your container to a public port, because once you do that, then you cannot scale your containers if you map it to a public port. You want to be able to have multiple instances of container come in without having to have new public ports for attached to that container. So these are some of the best practices, and they're all basically about keeping the process simple and clean. On API-based collaboration, we have talked a little bit all about these ones. We want to have published and versioned APIs. In SOA, we had different types of communication. We had all these XML and all. Now it's JSON serialization, which is more optimal in terms of its packaging, HTTP REST style APIs. These are generally followed in microservices architecture. We want to be able to deploy functionality independent of others, not break API contracts. We want to verify the interaction between multiple microservices through consumer-driven contracts. This is the way we want to make sure that when a microservice is updated, all its dependent services do not have to be updated at the same time. Self-service agile infrastructure, this is another important aspect where if you want to be able to deploy your cloud native application, the platform has to provide a lot of capabilities. For the business capability teams, that they can independently deploy themselves, not depend on a platform operations team. The platform operations team only has to deploy and operate the platform. We need to provide a higher abstraction level for the platforms, automated scaling, application health management, dynamic routing, and aggregation of logs and metrics. So these are all the requirements on the platform itself that provides the self-service infrastructure. And then monitoring is another important aspect. If we want to be able to scale, we want to be able to make everything visible, what's happening when in your deployment environment. And hence monitoring becomes very important, because you can also have very heterogeneous environments, especially with microservices. You can have multiple languages based microservices, multiple tools, multiple infrastructure, multiple databases that are there. You want to have a single point where everything is visible. You want to be able to detect all anomalies. They need to be intuitive. We want to have health check mechanisms so that either when you want to scale or when you want to start or restart, you need that capability so that when something goes down, you need to detect and restart them quickly. Capacity, it should help in capacity planning, and a real-time dashboard that provides how to monitor all the scaling and infrastructure changes. So this actually brings up all the 5-6 requirements for a cloud-native application to a conclusion. And in summary, if you have all these things and if you build your application with these capabilities, then every function that you want to provide on your cloud will meet the requirements that Srikanth was talking about. So these are some of the references that are there that really talk a lot about cloud native, what you need to do. There is a cloud native foundation. Cloud Foundry is also heavily into cloud native. There are lots of presentations both on the YouTube or SlideShare everywhere that provide these capabilities. So if you use that, then it will be easy to build a cloud native application. Sometimes it's not easy. We run into a lot of problems, but building it this way has really helped us to move very fast. And probably in 6-7 months, we have built a whole bunch of applications now. There's about 70 microservices, and we'll be going to preview soon with customers. So.
Okay, let's give another big hand for Prakash Bhattacharya as well as Srikanth Kannan. Thanks everyone for attending the meetup, and that concludes our session here. Questions are available for
any questions,
for
please feel
Prakash and
free.
Sri.
I'll be here, we can just talk.
Okay, great. Thank you.
All right, thank you.